In this video, I'm going to talk through how to factor a quadratic polynomial. So when I say factor, let's first talk about what that even means. So let's start with the expression 5n plus 4 times n plus 3. So I'm multiplying two linear binomials, and we've talked about how to multiply before. So if I wanted to multiply these two binomials, we can either draw a box or using the error model, or we can use a distributive property, which a lot of people call FOIL. So I'm going to first, with this first method of factoring, I'm going to show you how to do this with using the distributive property. Distributive property meaning I have to multiply this term times everything in this polynomial, and this term times everything in that polynomial or binomial. So 5n times n is 5n squared. 5n times 3 is a positive 15n. 4 times n is a positive 4n. And 4 times 3 is 12. Then I combine like terms to get 5n squared plus 19n plus 12. So this is called multiplying or using the distributive property, going this direction. And what factoring is you start with the polynomial in standard form, and we want to work backwards to get to the factored form, or the product of binomials, the product of its factors. So I'm going to leave this here, and I'm going to use another board to talk about, well, how do we do that? Excuse me. So where we're going to start is using the guess and check method. And guess and check method is essentially just the reverse of the distributive property, or reverse of FOIL. So we're going to first look at the first term, 5n squared. And my question to you is, where do we get the 5n squared from? Well, we find that the first two terms in these binomials multiply to be 5n squared. So that's going to be an important fact. In addition, we look at the very last term, and that 12 back here came from multiplying the last two terms. So if I'm working backwards, what I need to recognize is that the first two terms in my binomials will be two things that multiply to be the first term in the trinomial in standard form, and the last two terms in the two binomials will multiply to be the last term. All right, and then we have to figure out, well, where does this 19n come into play? Well, where that comes into play is once you multiply these out, these inner terms times the outer terms, so that 15n and 4n add to be 19n. So we're going to use that fact. So let's use the same exact problem and work backwards. We're going to start with 5n squared plus 19n plus 12. And I know that I want it to look like factored form, in other words, the product of two binomials. And so how I do that is I say, okay, well, you have 5n squared, and I want two things that multiply to be 5n squared. Well, I look at first the number 5. The only thing that multiplies to be 5 is 5 times 1, because 5 is a prime number. So I know there's going to have to be a 5 here and a 1 here. And then n squared, I realize, is just n times n. So I'll have an n here and an n here. So now this is set up so that the first two terms multiply to be the first term in the trinomial. And then we look at this last term, this 12. And I want two numbers here that will multiply to be 12, because if I'm using the distributive property and working backwards, that constant term I get from multiplying the two constants in the binomials. Well, this is where it gets a little trickier, because there's a lot of things that multiply to be 12. So 1 times 12, 2 times 6, and 3 times 4. So we have a couple different options. And so what we have to do is test them out. So let's first try the 1 times 12. We have a 1 and a 12 here. So if I put plus 1 plus 12, I can check to see do my linear terms, or the n terms, add to be the 19. And I'm going to get the two terms by multiplying 5n times 12 would be 60n. 1 times 1n is 1n. Well, when I add these up, these two add to be 61n. And that's not what we want. Okay? So that combination is not going to work. So I can erase that. That's not going to work. We don't want the plus 1 and plus 12. Okay. So that guy, not working. Let's try the 2 and the 6. Okay? So now when I check my inners and my outers to see if they add up to be 19, these two multiply to be 2n. These two multiply to be 30n, which they add to be 32n. But that's not what I wanted. I wanted 19n. So 2 and 6 isn't going to work. You know what we didn't try for the other one, though, was switching the order. Okay, so let's switch the order. We had a 2 here and a 6 here. Let's try the 6 here and the 2 here. So now when I multiply, I get 6n and 10n. That's 16n. Not quite what I want. So there really are a couple different combinations. We can't even just try them in one spot. All right, so now let's move on to the 3 and the 4. 3n, or 3 and 4. So now when I test it, excuse me, I check my inners, that's 3n. My outers is 20n. Those add to be 23n, which is not the 19n that I wanted. So those won't work. So we'll erase that and try a different order. Let's try the 4 here and the 3 here. So now when I check my inners and outers, that's 4n, this is 15n, those add to give me the 19n. So this would be my correct factored form, right here. And the reason why is that if I multiply this out to check my answer, 5n times 1n is 5n squared, 5n times 3 is 15n, 4 times 1n is 4n, 4 times 3 is 12, and when I combine those like terms, I get that back. And so we knew that because the beginning problem was that, but this is how I would work backwards. This is, a lot of people call this the guess and check method. It's just the reverse of the distributive property. And the guessing and checking comes into play when there are multiple factors that multiply to be any number. So that would be the guess and check method. So other things that will come into play are understanding the signs, are the signs positive or negative, and so on. So that's something else that will play a role in knowing whether or not which numbers we should have. So that is the guess and check method.